Alright, this is the fourth video for section 7.3, and we're going to be looking at how to find the slope in polar form. If f is a differentiable function of theta, then the slope of the tangent to the graph r equals f of theta at the point r comma theta is dy over dx, which is equal to dy d theta over dx d theta, or f of theta cosine theta plus f prime of theta sine of theta divided by f prime of theta cosine theta minus f prime of theta sine of theta. So let's see how we came about this. Well, x is equal to r cosine of theta and y is equal to r sine of theta. R is f of theta, so x is equal to f of theta cosine theta, and y is equal to f of theta sine of theta. So then dy d theta is equal to, let's say it's the first function times the derivative of the second, so derivative of the sine would be cosine, plus the derivative of the first, f prime of theta, times the derivative of the second function of sine of theta. Dx d theta, okay, and derivative of f, the f prime of theta, times the second function of cosine of theta, and then plus f of theta times the derivative of cosine, which would be minus sine, so we go ahead and say minus f prime of theta sine of theta. And it doesn't have to be exactly in this order, but you just have to have the appropriate terms in the numerator and the denominator. Okay, so let's look at an application. So we're going to find all horizontal and vertical tangents of r equals 3 cosine of theta. X is equal to r cosine of theta, which is equal to 3 cosine of theta, which is equal to 3 cosine squared of theta. Dx d theta is equal to 6 cosine of theta times negative sine of theta. And we want to know when that's equal to 0. So as long as not both the dy d theta and the dx d theta are simultaneously 0, then we have found the horizontal and the vertical tangents. So when the denominator is equal to 0, we're going to have our vertical tangents. So the values here, sine is 0 at 0, cosine is 0 at pi over 2, sine is 0 at pi, cosine is 0 at 3 pi over 2, and sine is 0 at 2 pi. So we'll just do the unit circle. And then you'll see in the next slide that we covered everybody. Okay. Now y is equal to r sine of theta, which is equal to 3 cosine of theta sine of theta. So dy d theta is equal to 3 times negative sine of theta times sine of theta plus 3 cosine of theta times cosine of theta. And we're going to set that equal to 0 to find our horizontal tangents. So we can add the negative 3 sine squared to both sides. And so basically we're going to have sine squared of theta is equal to cosine squared theta. Where the sine and the cosine squares are going to be equal to is at the 45-degree angles. That is pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. The sine and the cosine at each one of these angles is going to be either root 2 over 2 or negative root 2 over 2. When you square that, they're going to be the same value. Okay. Notice that none of the places where we potentially have horizontal tangents and vertical tangents are the same value, so we're good there. So let's move on to the next slide here. And again, so I have the graph. This is a graph from the OpenStax Calculus Volume 2 textbook. I believe it's on page 645 or 465. I don't remember the exactly, but it's in section 7.3. Okay, so let's just put in our graph. R equals 3 cosine theta. X is equal to 3 cosine squared theta. y is equal to 3 sine theta cosine theta. Okay, 1, 2, 3. Let's go ahead and graph r equals 3 cosine of theta. So the cosine of 0 is 1 times 3 is 3. And then cosine of pi over 2 is 0. Cosine of pi is, let's see, cosine of pi is negative 1 times 3 is 3. Okay. And so all of this negative portion here, that's going to be sent back this way. Okay. And so we get a full, it's just a circle. Now we just get a circle here. Okay. All right, so dx d theta was equal to 0 when theta was equal to 0, pi over 2, pi, 3 pi over 2, and 2 pi. So when theta is equal to 0, we're going to plug that in for the x and the y. So the x is 3 cosine squared, so that's just going to be 3. Now the y, because it has a sign right there, the sign of 0 is 0. So that gives us the point 3, 0. And so we have a vertical tangent there at 3, 0. Okay, now let's plug in pi over 2. Okay, the cosine of pi over 2 is 1, so the x-coordinate would be 0. And likewise, the y-coordinate would be 0 because they both have a factor of cosine. So that gives us a vertical tangent at the origin at 0, 0. When you plug in pi, the cosine of pi is negative 1, but we're going to square that, so that becomes positive 1 times 3 is 3, so your x-coordinate is 3. The sine of pi is 0. So we actually get the same point again, so we don't need to list it again. And we are listing it here just to kind of get an idea of what's going on here. All right, now theta is equal to 3 pi over 2. Okay, both x and y have a factor of cosine. Cosine of 3 pi over 2 is 0, so those both go away. It becomes 0. And one more, theta is equal to 2 pi. It's just going to be a repetition of 0, so we get 3, 0. So we have located the two places where we have vertical tangents at the origin or the pole, 0, 0, and then the point 3, 0. dy d theta was equal to 0 when theta was equal to pi over 4, 3 pi over 4, 5 pi over 4, 5 pi over 7. I had 7 on the brain, it looks like. 5 pi over 4, and 7 pi over 4. Okay. Now when theta is equal to pi over 4, you're going to have root 2 over 2 squared, which is just going to be 1/2, times 3 is going to be 3 over 2. Okay. Root 2 over 2 times root 2 over 2 is going to be 1/2 times 3. It's going to be 3 over 2. So we have a horizontal tangent at 3 over 2, 3 over 2. Okay, let's try the next theta, which is going to be 3 pi over 4. Okay. Cosine of 3 pi over 4 is going to be a negative root 2 over 2. Square it becomes 1/2 times 3. It's 3 over 2. Okay. Now plug that in. You're going to have negative root 2 over 2 times positive root 2 over 2, which is going to be a negative 1/2 times 3. It's going to be negative 3 over 2. So it gives us the point 3 over 2, negative 3/2 for a horizontal tangent. Theta equals 5 pi over 4. Plug that in. And the cosine squared, that's going to be a negative root 2 over 2 squared, which is 1/2 times 3. It's 3 over 2. And then both the sine and the cosine, at 5 pi over 4 are going to be negative. So you got negative root 2 over 2 times negative root 2 over 2. That's going to be 1/2 times 3 is 3 over 2. So we got the same point again. And lastly, we'll do theta is equal to 7 pi over 4. So we plug in 7 pi over 4. Cosine of 7 pi over 4 is root 2 over 2. Square that. It gives us 1/2 times 3 is 3 over 2. Okay, the sine is 7 pi over 4 is negative root 2 over 2, and the cosine at 7 pi over 4 is positive root 2 over 2. So that'll be a negative 1/2, and multiply them times 3 gives us negative 3 over 2, and we have a repetition there. And so we have all the vertical and horizontal tangents found there. So if we Keep listing out solutions to dx d theta equals 0 and dy d theta equals 0. We're going to just get the same 2 points over and over again. All right, well, that's it for this video. Stay tuned for 7-4.